Hello students, welcome back to the math class. Today we are going to start from exercise 10.3 second question. Already we have finished question number 1 and question number 3, but the second question it includes some construction, so that's why I have left this question. So now we are going to start. In this question we have given that suppose you are given a circle, then give a construction to find its center. Means one circle is given to us and we need to find out the center of the circle. So see how we can find out this one. First of all, what shall we do it? We shall draw one circle. So for that, I will use the rounder and we will draw one circle. So suppose this is our circle that we have drawn. Okay. Now we will take here. See, we need to find out here in this circle we need to find out its center, but you can see the center is already located over there. When you will draw the circle with the help of your rounder, your circle will be also located already, but we will see the method how directly we can find out the center of the circle if we are unable to find out with the any other method. So first we will draw the circle. Now here we shall draw two lines. We shall take 3 points actually and will join that 3 points with the help of line. So this is my first line and 2 points I have taken. Now from the second point again I will draw the second line. Okay, so actually I have drawn here two lines. This point, first one I can give the name A, second point I can give the name B, and third one I can give the name as C. Okay, now we shall draw the perpendicular bisector of both the lines. So for that we shall take rounder again, and now we shall keep it on one of the end, and with the help of rounder we shall measure the length of more than half of the length of we shall measure more than half length of the given line. Suppose that if we are taking the second line, so you can see I am measuring more than half. This will be nearby half. Don't take less than half. It can be less than half. So we shall take more than half of the total length of the line. Now we shall cut the arc. This is the first arc I am going to cut. Similarly, I will take the rounder downside and we shall cut the second arc. Okay, now we shall keep the rounder at this place. Do not do not change the length of the rounder. Okay, and again we shall keep it at this place, and now we shall cut the arc again with the same length. Again take it at the upside, and again we can cut the arc. Now you can see we have successfully drawn the perpendicular bisector of second line. Now we shall draw the line between the 2 points of intersection. I think it is not coming proper. We shall try to draw once again. From this point to this point we have to draw a line. See, my line is not going little further from the point of intersection, so you need to draw this line little further also. Don't draw it from point to point only. Okay, since I have the limitations in the tool, I cannot draw it little further upward and then downward. So but according to the proper construction method, you need to draw little down also, and you need to extend your line little upward also. Now once again see the method of making perpendicular bisector for the first line. Second line we have drawn. Now we are going to see for the first line. Okay, so again I will take the rounder over here. Now first I will measure the length more than half. You can see this will be the more than half length. Okay, now we shall cut the arc over here. This is the first arc I am going to cut. Okay, and in the same way I am going to cut the second arc. Now we shall keep the rounder at this place at the second point, and we shall draw the arc again. Same way we can bring the rounder at this place and we'll cut the arc. Now we shall draw the line between them again from one point of intersection to the another point of intersection. Now you can see how perfectly we have drawn the perpendicular bisector of the line, as well as you can see both the perpendicular bisectors, they are intersecting at the center only. See, earlier only the center was located. Now you can see the center particularly. In this center, you see, earlier we were knowing that this is the center, but see, suppose if we are not knowing, this will be the center of the circle. With the help of this method also, we can easily locate the center of the circle. Now this center we can mark as center O, which will be the center of the circle. This way you try to draw the perpendicular bisector. If you get any problem or if you have any confusion, then let me know. We can do this particular construction on the paper also. Okay, now let us see the question number 1 of exercise 10.4 along with the two theorems 10.6 and 10.7. Now I am going to explain you two theorems before the exercise 10.4. We are going to start the questions of 10.4, but before that these two theorems we have to finish. First, the theorem number 10.6. 10.5 theorem, as I have told you, that is not in our syllabus, so we are not going to discuss about that. So 10.6 we have given here equal chords of a circle, means we have given that one circle, you can see the figure, and we have given that two chords are equal. The name of that two chords in the figure we have taken as PQ and RS. Okay, now they are saying they are equidistant from the center. Equidistant, this word means if you calculate the length from the center to the chord, that will come equal. In the case of PQ, that length is OL. You can see from the center to the chord, the length is OL for the chord PQ. Okay, and similarly from the center to the chord, the length is OM for the chord RS. So if these two chords are equal, then the length from the center to the chord will be also equal. Means OL and OM will be also equal over here. So here we can write down what you need to apply these theorems. So first you required the given. What given you required? Given you required here chord PQ. Chord PQ is equal to chord RS. These two chords are required equal. Okay, and as a as a result, what do you get here? Result will be, in that case, the length of OL will be equal to OM. OL and OM are actually the length of perpendicular from the center to the chord. Why we have taken the perpendicular here? Because the perpendicular distance is the only distance we calculate if we want to calculate the distance between any two objects. Okay, suppose if I want to calculate the distance between two objects, so I will always take the perpendicular length. That will give us the shortest value of the between the two objects. Okay, now theorem number 10.7 we can see. In the theorem number 10.7, it is just the converse of 10.6. It is given over here chords equidistant from the center of a circle are equal in length. Means if the chords are at equal distance, then they will be also equal. Means it is just opposite of 10.6. For example, here if I write down the given, then here given will be OL is equal to OM, that is given to us, and as a result what do we get here? The result we will get here as the chord PQ will be equal to chord RS. Means if they are having the same distance from the center, means OL and OM are equal, then the chord PQ and RS are equal. Now let us start the first question of exercise 10.4. Yes, in the question number 1, now see what we have given to us. In the first question you observe, we have given here two circles of radii 5 and 3 centimeter. So you can see the one circle I have drawn little smaller, which can be the radius of 3 centimeter, and one is bigger, which can be the radius of 5 centimeter. And they are intersecting at 2 points. Okay, that 2 points will mention in the figure. Distance between their center is given here as 4 centimeter. Then we have to find out the length of common chord. You can see one chord is there whose length we need to find out. So first of all we shall do the labeling and we shall understand the question first, what exactly we have given here. So first I am giving the name of the center of both the circle as P and Q. So suppose here P and Q are the center of the circles. Okay, then the length of PQ means distance between PQ is given here as 4 centimeter. Here I will mark this length is given to us as 4 centimeter. Okay, that is one thing you can check. They are saying the distance between their center is 4 centimeter. Now one more thing, here I will suppose this will be a common chord. The name of common chord I am giving as AB. Okay, so this point I am supposing as A and this point I am supposing as B. Observe carefully, AB lies in the smaller circle also and AB lies in the bigger circle also. So we can say that chord AB is a common chord between the two circles. Right? Now what they are giving us further? They are saying two circles of radii 5 centimeter and 3 centimeter. Means the smaller circle have the radii 3 centimeter, one thing, and the bigger circle have the radii 5 centimeter. Okay, you check over here. I have taken the length of PA and QA as 3 and 5 centimeter because they are the radii of the two different circles. How we can say PA is the radius? Because the length between center to any point on the circumference of the circle is called as the radius of the circle. So this is all given. We have to find out the length of common chord, means length of AB we need to find out over here. AB and the line joining the center are intersecting at a point over here. So this point I will suppose as point M. Okay, I will mark once again. It should be visible clearly. So this point I will mark as point M. Okay, now to begin with the question, first of all we shall revise one question. We have done it earlier. What is that question over here? I will show you. First of all we shall go back to the exercise 10.3 and see one question we have covered in 10.3, question number 3rd. In this question you observe what was given to us. If two circles intersect at 2 points, in the question number 1 also they are intersecting at 2 different points. Prove that the center lie on the perpendicular bisector of common chord. Suppose that if we say AB is a common chord and one line which is passing through P and Q is the perpendicular bisector. Okay, so suppose if we are saying the line is passing from P and Q, then it will be definitely a perpendicular bisector of AB. So the line passing through the centers will be the perpendicular bisector of common chord that we have proved in this question. Okay, so in this question basically what was given to us? We have given that AB is a common chord. Then we have proved the line passing from the center means the line PQ is the perpendicular bisector of common chord, that we have proved. So if in any other further question we have given that AB is a common chord and we have a line passing through their centers of the two circles, we can assume the line passing through the center is a perpendicular bisector of common chord. You can see the same condition is given in this question also. So we can say that here PQ is a perpendicular bisector of common chord, because here also we have given that sorry, AB is a common chord here, one thing, and the line PQ is intersecting AB at M, and PQ is the line passing through the center. So PQ will be definitely the perpendicular bisector of common chord. Okay, so let us write down the given things first. First, we shall mention in the given what we have given here. In the given, first we'll write down we have two circles with centers P, Q and radii. Now see, circle having the center P is having the radius 3 centimeters. So 3, 5 centimeter respectively. Right? Now further we can write down AB is a common chord. AB is a common chord and distance between their center means length of PQ. PQ is given here as 4 centimeter. So these are all given things in the question. Okay, now let us see how we can find out the required things. First, we shall mention here to find. So what we need to find out here? Length of AB. So let us mention here length of AB. Okay, let us find out in the solution further. Now, first of all, as we have discussed earlier, that the line joining the center is always a perpendicular bisector of a common chord. So here we can say that PQ is the perpendicular bisector of common chord AB, and hence AM and BM are equal, one thing, and at the point M the angle would be formed of 90 degree, that we can mark now. Okay, so first of all we shall provide that given over here. So first we will mention in the solution, since AB is a common chord, AB is a common chord and line joining through center. Line joining through center, that is PQ, is a perpendicular bisector of chord AB. So therefore, what we will get here? Therefore, we can say that AM is equal to BM, both are equal, and since both are equal, they will be half of AB. Okay, because AB will have only two equal parts in that case. So therefore, we can say that AM and BM equal, they will be half of AB. And one more thing we will get here, PQ is perpendicular to AB at M, that we can see. Now let us see further one more thing we can suppose over here. One thing you observe, in the chord PQ, the total length, in the distance between the center that is given as PQ, we have given that the length of PQ is 4 centimeter. Now suppose if I say PM is equal to 1 centimeter. For example, okay, suppose PM is equal to 1 centimeter, and one more thing I can say PQ PQ is equal to PM plus QM, that we can write down here. Okay, so if I put up the value of PM as 1, PQ as 4, because length of PQ is given 4 here, so from here I can find out the length of QM as 3 centimeter. So how do I get 3 over here? By subtracting the length of PM from the length of PQ. Means if you want to obtain the length of QM, then you need to subtract PM from the total length, that is PQ. So here what shall we do it? We shall suppose the length of PM as x centimeter. Okay, so we can say that in that case what will be the length of QM? The length of QM will be from the total length, that is 4, we shall subtract the length of PM, that is x. Means here I am supposing the length of PM as x centimeter. To obtain the length of QM, just now I have explained you, from the total length, means from the 4 centimeter, we shall subtract the length of PM, that is x. So here I can say that the length of QM will be 4 minus x centimeter, because here we don't know what exactly a length of PM would be. Okay, it can be 1 or it can be 1.5 also. So here I am supposing that is x over here. So I can find out correspondingly the length of QM. Now look at the triangle AMP. Triangle AMP is a right angle triangle. Okay, so we shall apply Pythagoras theorem. So further I am writing here, now in a right triangle AMP, in a right, you can write down right angle triangle also. So right triangle AMP, who will be the hypotenuse here, which comes in front of the 90-degree angle. So AP will be the hypotenuse here. So we can say that square of AP is equal to square of AM plus square of PM. Okay, here reason we can give by Pythagoras theorem. Now further, what is the value of AP? Value of AP is given in the question as 3. So we can keep it here, square of 3. Now look at the AM. AM we do not have any value. So we shall keep AM as it is. Okay, you can see in the figure. AM we do not have any value. And PM we have supposed here as x centimeter. Okay, so we can say that AM we can keep it as it is. And PM I am keeping here x square. So from here I can say that the value of square of AM is equal to 9 minus x square. Equation number, this will be second. Now in the similar way I will take the another triangle, that is BMP. So now I am taking in a right triangle BMP. Okay, here same way we can write down BP will be the hypotenuse. So we can write down square of BP is equal to square of BM plus square of PM. Once again, I have applied the Pythagoras theorem. You can check in front of the angle of 90 degree. The side is coming over here as, sorry, I have applied the wrong triangle here. We can change it. It is triangle AMQ. By mistakenly, I have written BMP. So we'll make a correction. Sorry, here we'll make a correction. Triangle AMQ it is. Once again, we'll write down. Okay, first we'll make a triangle name here as AMQ. Now observe please. Okay, in the triangle AMQ, observe, we have given that angle M is of 90 degree. And second thing you observe, AQ is the hypotenuse. Why? Because AQ is coming in front of 90 degree angle. Angle M will be of 90 degree. So AQ is hypotenuse while AM and QM will be the other two sides of the triangle. So now further we shall write down AQ square is equal to AM square plus QM square. Okay, again AQ will be equal to here 5. Okay, AM value we don't know, so we are keeping AM square as it is, and QM you observe we have supposed here as 4 minus x the whole square. You can check once the value of QM. Okay, see in the figure. Here you observe the QM is given here as 4 minus x. Okay, we have considered like that, while AQ value will be equal to 5 centimeter. Now we shall go further. Square of 5 will be equal to 25, right? And AM square I am writing as it is. And this one I am going to open by the formula A minus B the whole square. So that will be A square plus B square and minus 2AB. So 2 into 4 into x. Now let us simplify further. So this will be 25 is equal to AM square plus 16 plus x square minus 2 into 4 8x. Now you see the value of AM square we have already from the equation number second. Look at the top, AM square is equal to 9 minus x square. So let us put up the value of AM square. Remember we are keeping directly the value of AM square. So that is 9 minus x square plus 16 plus x square minus 8x. Here x square and x square got cancelled. Okay, and we can write down the reason over here by equation number second. Now let us simplify further. 16 plus 9 will become 25 here. So it can be written as 25 is equal to, again, 25 minus 8x. Now 25 and 25 will be cancelled. So we can say that therefore minus of 8x will be equal to 0, or the value of x is equal to 0 upon minus 8 will be again equal to 0. So we can say the value of x is equal to 0. Now this value of x I will keep in the equation number second to get the value of AM. Observe, in the equation number second we will keep the value of x to get the value of AM. So here further I will write down, therefore by equation second AM square is equal to 9 minus the value of x I am keeping here 0. So it will be square of 0. So we can say that therefore square of am is equal to, here what will remain? 9. So 9 we can write down square of 3, or we can say square and square if I cancel. So am will be equal to 3 centimeter. Now value of am I will keep in the equation number first. Look at the first equation. Okay, here I am ignoring the bm here because bm is not required. We'll take relation directly between am and half of ab. Okay, so here we are taking from the equation number 1. So further we shall write down now by equation 1. Therefore by equation 1 what we have? am is equal to half of ab, right? Put up the value of am there. Am we have 3 centimeter is equal to 1 upon 2 into AB. Now 2 I will transfer onto that side. So am I will get here as 6 centimeter. Sorry, not am. AB I will get as 6 centimeter. And that is your answer. One more thing, you see the value of x we got 0 over there. So x we got 0 means if I put up the value in the figure, you observe what we have supposed x here. X we have supposed as pm. So the length of pm is coming 0. So in that case, if you draw this figure with the help of construction tools, then the smaller circle will come inside the bigger circle and it will touch the bigger circle at only one point. It may not touch at the 2 points. Okay, so that we may get at the with the help of construction tool, we cannot analyze that things in the beginning. But now algebraically, since the value of pm is coming here 0 centimeter, so we can say that the smaller circle will come inside the bigger circle and it will touch the circle at one point only. Okay, so this complete the question number 4. Now next time onwards we can start from question number 2 onwards. Thank you.